So, have you ever stopped to think about how we're going to power the trillions of devices in the future Internet of Things? Well, today we're going to dive into a pretty wild technology with a radical answer. What if we just don't power them at all? This is all about a truly game-changing idea called ambient backscatter.
Yeah, that question right there, that is the central challenge for our whole connected future. The big dream of the Internet of Things, the IoT, is to stick a little bit of smarts into literally everything around us. But that amazing vision smacks right into a very real, very physical wall.
1 trillion. Just look at that number. Now, try to imagine the sheer, mind-boggling logistics of changing the battery in a trillion different gadgets. I mean, it's not just a hassle. It's a complete environmental and economic nightmare. There's just no way we can get there with the batteries we have today.
So, it turns out, our biggest hurdle isn't about processing power or super fast networks. Nope. It's the humble battery. If we're ever going to unlock that truly smart, connected world, we absolutely have to figure out a way to cut the cord and let these things talk to each other without their own power source.
Okay, so how in the world is that even possible? Well, the solution is actually surprisingly simple, and it's based on something we see every single day. Instead of generating their own signal, kind of like shouting, what if these devices could just reflect?
And this right here is a huge shift in how we think about communication. A normal radio, like the one in your phone, it's basically a flashlight. It has to burn its own battery power to create and shine a signal. But a backscatter device, it's more like a mirror. It doesn't need to make any energy. It just has to cleverly reflect the energy that's already floating around in the air.
Okay, now this is the really clever part. The device's antenna acts like a tiny switch or a gate for radio waves. In one position, the gate is open and it just absorbs the incoming signal. Let's call that a binary 0. Then, instantly, it flips the switch, the gate closes, and it reflects the wave away, and that's our binary 1. Just by flicking that switch back and forth, absorb, reflect, it can spell out any message it wants in ones and zeros.
All right, that's a pretty smart way to send data without power, but it still leaves one big question, right? Where does that initial signal, the one it's reflecting, even come from? Well, this is where the real magic of ambient backscatter comes in.
So this idea has an older cousin you've almost certainly run into, RFID. Like the security tags in a store or the key card you use to get into your office. It works on a similar principle, but there's a catch. It needs a special powered-up reader right next to it to blast out a signal for the tag to reflect. And that right there really limits its range and what you can do with it.
Ambient backscatter is the huge leap forward. Instead of needing its own special reader, these new devices can use the radio signals that are already flooding the air all around us, all the time. They can basically hijack or piggyback on existing signals to get their own messages out. And what kind of signals are we talking about? Well, they're literally everywhere. Right now, the air around you is just saturated with energy from TV broadcasts, from Wi-Fi routers, from cell towers, even old-school FM radio. Ambient backscatter devices can tap into any of this stuff and use it as both a signal to reflect and a tiny source of power.
Yeah, let that sink in for a second. These things don't need a battery. They don't need to be plugged in. All they need is to be somewhere near the TV, Wi-Fi, or cell signals that we're already blasting out into the world anyway. This is what makes true, honest-to-goodness battery-free communication possible.
Okay, so we've got the how down, it's clever, but now let's get to the really fun part. The what. What kind of world does a technology like this actually open up? Because the real-world applications, this is where things get absolutely mind-blowing. Think about our homes and our cities. We could literally plaster the inside of our walls with tiny set-it-and-forget-it sensors that could detect smoke or carbon monoxide forever, or embed them in a bridge to monitor its structural health for decades without ever needing to replace a battery. Your trash can could literally tell the garbage truck it's full just by reflecting the city's public Wi-Fi signal. How cool is that?
And for things like logistics and warehousing, oh, this is a complete revolution. Imagine every single box, every item in a giant warehouse having its own tiny, super cheap, battery-free tag. Shelves would just know their exact inventory in real time. This could finally get rid of all those blind spots that still cause headaches, even with the best RFID systems we have today. But maybe the most incredible applications are in medicine. Just imagine a sensor inside your body that could monitor something forever, with no need for another surgery just to replace a battery. It's an amazing idea, but it runs into one huge problem: our own skin. It turns out the reflection of the signal off the surface of your skin is way, way more powerful than the tiny little signal coming from the implant inside. And when I say way more powerful, I mean it. 8 orders of magnitude means the noisy reflection from your skin is 100 million times stronger than the signal you're actually trying to listen for. That's not just a little interference. That's like trying to hear a single pin drop during a rocket launch. The signal you want is just gone, completely drowned out. So the solution to this is just beautiful engineering. A system they call Remix uses a special little circuit that does something really clever. Instead of just reflecting the signal as is, it actually changes it, shifting it to a whole new frequency. It's kind of like adding a secret invisible dye to the signal before sending it out. The receiver on the outside isn't listening for the original signal anymore. It's just looking for that unique dye. The powerful reflection from the skin doesn't have the dye, so the receiver just ignores it completely. The interference just vanishes. And solving that one problem unlocks a whole new frontier in medicine. Now we're talking about things like smart contact lenses that can measure your glucose levels from your tears nonstop, or heart rate and breathing monitors that are literally woven into the fabric of your shirt, or even tiny sensors you could swallow that report back as they travel through your body. All of it communicating without a single battery. So you're probably wondering, how much power does one of these clever frequency-shifting tags actually use? Get this, a tiny 45 microwatts. I mean, that is an unbelievably small amount of power. It's so little that the device can easily harvest all the energy it needs right out of the air from the same radio waves it's using to communicate. So this tech is already amazing, but of course, it's not stopping here. The next big step, the next evolution, is all about making the environment itself an active part of the conversation. Just think about this for a second. What if the walls around you didn't just get in the way of signals? What if the walls themselves could be designed to intelligently catch a signal and steer it exactly where you want it to go? Well, that is the core idea behind something called Reconfigurable Intelligent Surfaces, or RAS for short. You can pretty much think of them as smart mirrors, but for radio waves. They're these special programmable surfaces that can take an incoming signal and reflect it, not just anywhere, but in a very specific, tightly controlled beam. So, why is that such a big deal? Well, remember, these backscatter signals are super weak. They lose power on the way to the tiny device, and then they lose even more power on the reflection back. It's called double fading. But if you can turn a boring old wall into a smart mirror that focuses all that signal into one powerful beam, well, now you can blow right past that limitation. It means these battery-free connections can become way stronger, much more reliable, and work over much longer distances. When you really think about it, this technology isn't just a small improvement. It's a total rewrite of the rules for connecting our world. By learning how to sip energy from the air around us, we get to remove the battery. And that's the single biggest thing holding back a truly connected planet. And all that leaves us with one really exciting question to think about.